Hello, this is Gabriel, and today we're going to be coding the game Snake in Python. Um, this tutorial will be pretty beginner. However, you should have a basic understanding of how Python works before going into it. Um, Now, I'm just using this environment, Spider. However, any other environment is good. Um, and the main module that I'm going to be using for the game is called pygame, and that you have to download. So that's a very easy download. You can just look it up on YouTube. So I'm gonna start by just also I'm gonna be coding this game in an object-oriented manner. This is because Snake is a simple game. Um, this probably is not the most efficient way to code it. However, it's good practice, and it serves as a good introduction to coding in this object-oriented manner, which is very useful for any future games or any coding that you do in the future. So essentially, the first thing I'm going to be doing is importing the module pygame. Now, if you see here, you can see that the pygame ran. If there's an error called no module exists or pygame module does not exist, then you haven't installed it correctly. So what I'm going to do now is I'm also going to import the other two modules that we're going to be using. So import random. This is built into most Python environments. And import time, and this is also built in. So if you're unfamiliar with the game Snake, which I doubt many people are because it's a very popular game, essentially there's a here I'll bring it up, but essentially there's a snake that you can move around, and it eats apples, and then as it eats apples, it grows in size. Let me accept. So that's what we're going to be coding today. And if you notice the screen, there's three key kind of things that you have to code for. There's a snake, there's the apple, then there's just the game in general, and those three objects are going to be the classes that we're using. So I'm going to go ahead and write class snake. That's our first class. Then I'm just gonna write this in parentheses or like a hashtag for now, so the code doesn't get read, because that's kind of something we're gonna code for the apple later on in the game because it's not kind of a key component. Then class game. And as with any kind of code, all of my variables, they can be anything. Like you can name any of these different things. So, but I'm just naming them how I'm used to naming them, with the game class, which kind of contains the main game loop, and the snake, which is the main object. So now the first thing that we're gonna do is kind of create the screen for the game. And first things first, actually, I'm gonna label some colors. You don't have to do this, however, I find that it helps a lot just to label some basic colors for your actual game. So the color black is 000 on the color wheel. Color red, I typically, although red is 250 I like to use 200 because I think it's a softer color of red, and it's more aesthetically pleasing for me. And again, if you're coding this on your own, these colors can be anything that you want. Like you can put any numbers in there and it'll work. But I'm just using just basic RGB colors because it's easiest to do. White. And white is again the combination of all colors. I'll use 240 for this. Okay. So first things first, I'll put a note here. Is we're gonna as with any class, the first function that you put in the class is the init function. So it'll be def underscore underscore init underscore underscore and self screen width, screen height, and grid size. So I'll explain this in more detail in a little bit, but so basically, as with any function within a class, you always put self as the first one. So that serves as like a tool to be able to locate the function in a future like in a future script or a future function or future program. Then I'm going to introduce you to these two variables, screen width and screen height. These two variables will serve to actually be the width, the x length, and the y length of the screen that's going to be created. Then grid size. If I bring back the game of Snake, you can imagine everything in a grid. Like you can actually see it in here. But everything's on a grid. The snake moves on a grid, right angles, and objects form randomly in the grid. So that's where this grid size function or variable comes in. Then the first thing that I'm going to do with this initialize function is actually start pygame. So pygame.init. This function here, it just sends a signal to your computer to open up a separate tab of pygame. Next, I'm going to do self.screenWidth equals screen width. What this does is it takes the value that you put into the function and it actually turns it into an actual value because it turns it into because this is just kind of like an input. It's not an actual variable. And I'm gonna do the same thing with screen height and grid size. And then the first thing I'm gonna do is actually initialize the display or like create the display. And for this, I'm gonna create a variable called display, and I'm gonna use the function pygame.display.setMode. Now this is essentially the main function that is used in the module pygame in order to create the display. And what it does is it takes the screen width and the screen height, makes that the x and y coordinates of the screen. So I'll put self.screen width. This is the x, and self.screen height, and this is the y. So what this function does is it basically just takes a x, y coordinate, and the screen width is the x coordinate because it's width, and the screen height is the y coordinate because it's height. Then next, what I'm going to do is use pygame.display.setCaption. This is another built-in function in the pygame module, and with this, I'm going to name this function. Or I'm going to name what this does is it actually names the tab. It names the display. So I'm going to name the display snake. Now, okay, well, we can do this for now. Then now, what I'm going to do is I'm going to actually create a clock. So this is pretty straightforward, but self.clock equals pygame.time.clock. Why a clock is important is that basically the way games work in Python is you have a main game loop, and in that game loop you run through a bunch of functions, and based off the results of those functions your objects move and whatnot. However, you need to have a clock to make sure that the loop is running. Say if the clock is like 0.1 seconds, the loop will run every 0.1 seconds, so that everything updates and everything actually works. So that's why I'm creating a clock. Then this clock is a speed, and um, I will go ahead and make the speed called snake speed. That's what I'm gonna call it. 15. Let's do 15 milliseconds. So that's 0.15 seconds. Essentially, what this does is that um, later on in the actual loop, I'm going to at the end of the loop, I'm gonna have the clock tick, so that the clock reset every at the snake speed, so every 0.15 seconds. And what that does is it just kind of sets the frames per second of the game, and it kind of and yeah, and the frames per second is how fast the snake moves as well. Or that's not true, but yeah, but it sets the frames per second. But so this is kind of for now, this is all we'll do for the initialize function. And then we're also gonna then we're gonna start, I guess, with a class, a snake class. So the snake, it's going to be essentially a rectangle that can get longer, and the rectangle can move in 4 directions: right, left, up, down. And the rectangle, yeah, and the way probably the most complicated way about this, how the snake moves, is that if we look at the game, the snake moves in right angles, and the like say each square is one segment of the snake. The squares, they follow the same position as the last position. So if you look at, like, if you turn the positions behind where the snake turned keep their direction, so the whole snake doesn't move at once. So that's what we're going to be coding for now. That's our main object, the snake. So again, like for any object-oriented program, we're going to make an initialize function. So self. Now we're going to do different variables. So one of the variables we need is the display, because the snake is on the display, so we have to visualize how the snake changes based on the display. So we'll do display. Then one of them is grid size, because this determines the size of the snake and like how fast the snake moves. And then at the end, you don't need to do it this way, but I'm going to set the beginning x and y coordinates for a snake, because I just found this makes it quite easy. It makes it a little bit simpler. Then, like we did for the game class, we're gonna make these inputs into actual variables. So we're gonna do self.display. Sorry, display. Then we're gonna. That's all I'll do for now. But then we're gonna kind of write the 4 movements. So as functions. So turn left. Then again, for all object-oriented programming, you always put the self. Turn left. Right. Up. And turn down. So essentially, so let me see if I can. So essentially, the way screens initialize in essentially the way screens work in pygame is that, say this console area was a screen. 0, 0 is actually in the top left corner of the screen. Then if the screen was like 500 high and 1000 long, it'd be 0, 500 here, 500 or 1000 0 here, and 500 1000 here. So it kind of works. It's kind of a mirror image of or the inverse of a normal XY coordinate plane. So the 200 200 coordinate, if this is 0 0 and this is 1500, the 200 200 would probably be like around where my mouse is right now. So with that in mind, we're gonna have to use that for how to turn the movement works. So the first thing that I'm gonna do is I'm going to create an x coordinate. So self.x equals x, self.y equals y. So this is the initial. This means that the initial x coordinate is 200. The initial y coordinate is 200, and it also creates a variable x and y. Then I'm also going to create a variable self x change and y change. What these variables are going to be doing is actually, if you notice how the snake moves, in this, the snake moves. I only have to press the mouse or the arrows one time, and the snake keeps moving in that direction. And then, so essentially this x and y change is the reason why. I'll show you in a second. Then I'm going to create a list. Basically, the way the snake works, like I said previously, is that the snake, there's different blocks in the snake, and then you can add to these blocks, and as the snake eats apples, the blocks increase. Now, the way you create those blocks is by creating a list of snake blocks. So I'm going to call this snake list equals these. That's the list. And then I'm also going to create the start x and y coordinate. So it's the start. This is the initial coordinate. Then I'm going to start by adding the start to the snake list. So essentially what I did right here was I took the initial coordinates of the snake, 200, 200, and I added them to the snake list. So now the snake list would contain, it's a list, and it contains one variable, which it'd look like this. If you actually looked inside, it'd be 200, 200. It'd look like this, and then you can keep adding things on. So you can say if it moves right, you could add. You can make that like 200, or sorry, like 210. 200. So this is what the list actually looks like if you look inside of it. So at the beginning, it's just this. However, you can keep adding things based off the movement, which is what I'll do now. Oh, and then finally, length. I'm gonna make the length equal to 1. So there's one block at the beginning of the game. So turn left. So first, what happens when it turns left is the x moves to if it turns left, the x value decreases by the length by the amount that I want, by the grid size, because that's how you keep the snake looking all nice. So what I'm gonna do is I'm gonna write self.x change. So when the turn left function is called, the x change is going to minus equals means it's just going to decrease by the grid size. So and then the y change will be the same. So all equals 0. So what happens is essentially if turn left is called, then the change in x for that specific moment will decrease by the grid size, meaning that this object itself will be going to the left. Now I'm going to do the same thing with the turn right and turn up and turn down. So self.x change plus equals, so y change equals 0. Yep. Then finally for turn down. Now, this on its own is not going. And then also in the game, I'm gonna actually create the snake. So I'm gonna create a new variable called snake. So not very creative, but self.snake. And then what I'm gonna make this equal to is um, I'm gonna put it into the class snake. And then what I'm gonna do is the display is a self.display, which is right here. And then the other thing that I need to put into it is grid size. Then, as I defined it here, self.grid size. So what this does is it actually creates an object in the game, um, loop or area that is object that is called snake. So back to this. Now these controls on their own are not actually going to move the snake. They're just going to change these two variables here, the x change and y change. So what I'm going to have to do is I'm actually going to have to create a variable called move. What this does is actually takes the x value and I'm going to add it to self.xchange. This means that if turn left say is called, then when I decide to then in the future if I use the move, if I call the function move, then the x value is actually going to change by the value of x change, which was affected by turn left. So I'm going to do this with y as well. And I'm using plus equals because you want it to keep going forward, or you want it to keep going in the direction that you want it to go. However, I suppose that if you inverse everything, you could also use minus equals. However, that's not very useful in my opinion. So that's kind of the basic idea. Now what we're going to do is we're going to actually go back to the game loop, and we're going to initialize the actual game loop. So we're going to call this define game loop, and nothing is going to have to go into this game loop, it's just itself. So what I'm going to start by creating a variable called running. So let's put that here, self.running equals true. So then I'm going to create a while loop here, while self.running equals true. Then things happen. What this is going to do is it's just the basic while loop. As long as this running variable or boolean is true, then the game loop's gonna keep going. And then I'm gonna use the built-in function, so I'm gonna create a for loop within this while loop. So I'm gonna create a for loop within this while loop, and what I'm gonna call it is for event in pygame.event.get. This event.get is pygame.event.get is a built-in function into module pygame. Essentially, what it does is it gets any events from your keyboard or mouse or whatnot. So if you press the key F, that's considered an event. If you press spacebar, it's an event. So for each event in that, if the first thing I'm going to do is if event.type equals pygame.quit. So if the user wants to quit, then I'm going to make the self.running equal to false, and then I'm going to quit pygame. This is obviously important because if like if you want to stop the game, it's not gonna let you stop the game unless you put in this small thing, which actually cuts the loop, and it also cuts the display. And then also I'm gonna create another if statement. So if event dot type, so this is the type of event, equals pygame dot key down. So we're gonna be using the keys, arrow keys, to move the snake. If event dot type equals pygame dot key down, then there's different kind of nomers or names for each key. So I'm gonna create another if statement. So if event dot key equals pygame dot k dot write. So this kind of just signals to the computer, the pygame, that you're looking for a write key. So if the write key is pressed down, then self.snake. So I'm gonna go back to this object that I created, or right here. Go back to this the snake, which is an object of class snake. I'm gonna have the snake turn right if the right key is right. I'm gonna do the exact same thing for each key. So if the key equals pygame dot k left, self dot snake dot turn left. I can do that for up as well, and down. Alright, up. Finally, if event dot key equals pygame dot k down, self, we have the snake move down. Let's see. Yes. So that's the first thing. Oh, and also I'm gonna just for like if you want. Actually, I'll do it in the future. So what this does is that what the loop does first is it looks for any events. It looks if your key is down, and based off whether your key is down, it changes the x change and y change variable in your object of class snake. And then what I'm gonna do is I'm actually gonna do self.snake.move. So what this does is obviously it moves the snake. And then we're gonna fill the display because and then we actually have to create a variable. Actually no, we'll go ahead and fill the display. So self dot display dot fill black. What this does is it takes the display and it colors it black. Sorry, self dot black. You always have to put the self when you're working with object-oriented programming. And then we're going to use the command pygame dot display dot flip, which actually updates the screen. And then we're going to create a clock, and then we're gonna tick the clock. So we're gonna say how long the game is gonna wait for the next event. So self.snake speed, which is what I talked about at the very beginning of the video, if you don't remember. Let's see. What I'm gonna do now is I'm actually just gonna show what this shows up. The way I'm gonna do this, I'm gonna create, like outside of both classes, I'm gonna create a main function, and then I'm gonna do play game equals game. So this just creates a variable that's the object game. And then screen width will be 600, screen height will be 600, or sorry, 800, 600. Then grid size is gonna be 40. And play game, but game loop. What this does is it just calls for if this main function is called, then it'll play the game loop. And then this is just another way to call the actual program. So let's see if this runs. So what this did is, so far all we have done is we've created a display, a black display, and although it's not been drawn, there is a snake that is moving in the display. So what we're going to do now is we're actually going to draw the snake, and this is obviously very important. And this function goes in the game class, so we're going to name this function draw snake. And what we need in this function to draw a snake is we need a snake. We also need an object. We need something that is of the object snake in order to actually draw. So do snake. Let's see. And then for the snake, so we're gonna in this snake, okay, in this draw snake function, essentially, as I said before, the snake is comprised of different coordinates in a list, different sets of coordinates in a list, and the amount of coordinates that there are is based off the length of the snake. So as the snake increases in length, there will be more sets of coordinates in the list. So what I'm gonna do here is I'm actually gonna take the elements in the list, and for each coordinate set in the list, I'm gonna draw a rectangle of the snake. So I'm going to do 4 segments, so for the amount of different, for each segment in the list, in self.snake list. So this is the snake list in the object snake. We're going to use a command from pygame.draw.rect. So what this is going to do is it's going to draw a rectangle for each coordinate. Now there's 4 things that you put, or there's 3 things that you put into this this function pygame.draw.rect. The first thing is where you want to put it, so self.display. I want to put this snake on display. Next, we're gonna put the color of the snake. I'm gonna make mine red. Then we're gonna actually put in then there's a little bit more complicated. We're gonna do the X position, the Y position, and then the length and the width of the snake. So the X position of the snake is gonna be as I said before in the list. If you look at here, it contains coordinates, or it's like X, Y, like this. So the X coordinate is the 0 position of the list, because in Python lists start from 0, 1, 2, 3. So it'll be segment 0. That's the X coordinate of the list. That's the X coordinate of the segment, and the Y coordinate is a segment 1, because that's a Y. This is the first coordinate. This is the 1 position in the list. And then the length and width of the snake are gonna be grid size. So self.grid size, self.grid size. Then remember one more of these. So here we have let's see, I messed up some kind of indentation. Maybe it's this. Here, sorry, I'm just gonna put all of these back. Let's see, this is 1. Sorry for this. I always have to fix an indentation error, which is quite annoying. Sorry, segment. Or I'll change this. Okay, so with this, then I'm gonna go back into the game loop, and I'm gonna make it so that before display is updated by this function, we're gonna actually draw the snake. So self.draw snake, self.snake. Now what this does is quite obviously it just takes a snake and it draws it via this command onto the display. So it's not showing up. Let's see. Maybe I messed something up. Sorry. Oh, here. This is not. I don't think this will make a difference. Let's see. Confused by what this is saying. It's saying no. Oh, okay. It's saying that for some reason it's not finding my file, which is a little bit odd. Maybe I can save this. Snake P. Okay, it says the game object has no attribute draw snake. That is because there's indentation error. Sorry. Now this should work. Okay, as you can see here, I successfully drawn the snake, and now it's not. Yeah, I drew the snake. Let's see, and the snake should be moving. However, here, really get this quickly. Yeah, snake should be moving. Oh, and then sorry, the one thing to do is I have to do a self dot snake this dot. And then for this move function, I actually have to take these two x values and y values, and actually put them into or actually what I'm gonna do is I'm gonna create basically this x value and y value is the head of the snake, so I'm gonna create a new variable called snake head, and this is gonna be a coordinate of self.x, self.y, and then I'm gonna append the snake head into the snake list. Okay, now if I start this and I press the arrows, you can see that the snake is moving. However, the key problem with this is that the snake is only one. It should only be one segment long, yet it's too long. So what I'm gonna have to do here is I'm actually gonna have to ensure that the length of the snake drawn out is always the same length as the snake as it should be. So this is all very important using this variable snake length. So what I'm going to do is I'm going to right here, I'm going to, or actually right here, I'm going to create an if statement. So if the length of the snake list is actually greater than the snake length variable, then I'm going to delete the first position or position 0, so the first position of the coordinates in the snake list. So um, okay, so there this if statement serves to delete the first position of the snake list. So we can see here is it's just one rectangle, and every time it moves, because it's only snake length once, one, every time it moves, its kind of trail, I guess, gets deleted. So I'm gonna cancel this. So now uh, now I'm gonna start by, or now I'm gonna make make it so you can add segments to snake. I'm gonna create a function called add segment in the object snake. What this does is it essentially just allows for length of snake to increase. Def add segment, and all this function does is just increases self of snake length by +1. And what this means is that now using this function, the function will allow for 2 positions or 3 positions or as many positions as the snake length wants. And then just to show you how this works, I'll just create like kind of like a cheat, I guess. For now, I'll delete it later, but pygame.k space. So if I press space, uh, I want the snake to add segment. So now if I go here and I press space, you can see that the segment is moving, and it's moving the correct way because each individual segment is taking the position of the last segment. If that makes sense. Now there's a few key problems with this. First off, if there's no collisions, so if it collides with the boundaries, nothing happens. And second off, if it collides with itself, the snake shouldn't be able to collide with itself. So what I'm going to do for that is I'm going to create 2 more functions. Or for colliding with itself, I'll edit the snake object over here, the move function here, and then for colliding with the boundaries of the screen, I'll create another function. So I'm going to create the function boundary collision. So boundary collision. And within this function, basically if the snake's x value is less than 0, so meaning it's to the left of the display, or if the snake's x value is, or snake's y value is less than 0, which means it's above the screen, or if the snake's x value, is to the right of the screen, which means that it's greater than the screen width minus the size of the snake, which is itself the grid size. So, and I'm going to do the same thing with the y. So basically what this does is that it means that if the x value of the snake is further to the right than the screen width plus the grid size, like so basically the x value, the coordinate is the top left of each square, so you want to have some like space like between, yeah. So then self snake, and then I'm going to do the same thing with the y value. So then if any of these things happen, sorry, so I'll check that. Okay, if any of these happens, I want this boundary collision to return true. So elsewise, I want it to return false. So what I'm gonna do here is I'm gonna have I'm gonna create a yeah. So I'm gonna put this boundary. I'm gonna implement this boundary collision into the game loop. So I'm gonna write self that boundary collision, or if what I'm gonna do is I'm gonna do if self.boundary collision. Um, equals true, meaning if this function here returns true, I want the game to stop running. Yeah, and then if I sorry, oh, this is wrongly indentated. Okay, now if I go into the screen. Sorry, I think I spelled it wrong. Yes, I did spell it wrong. I spelled spoodery, not boundary. So I spelled grid size wrong as well. Where did I spell grid size wrong? Here. Now what this does is it means that this rectangle, every time it hits the edges, self-running is off. And just for now, I'm gonna put pygame.quit. I'm gonna have the game quit every time it hits the boundary. So I'll show you once again. If it hits the top, the game quits. Hits the left, the game quits. If it hits the right, the game quits. If it hits the bottom, the game quits. Now I'm gonna actually go back to the movement here for one brief moment. Now, what the problem with this right now is that if I press right twice, it kind of skips. Like, I'll add a segment to show you. Like, you can see that the game kind of skips. Yeah, it skips over one extra if I press right, like a key twice in a row. So for what I'm gonna do for this is I'm gonna implement a new if statements for all of these turn left and turn right and turn up and turn down. And the first if statement is gonna be if the x changes, if the change in x is already less than 0 for turn left, then just like skip. So just return skip turn left because the snake is already moving left. I'm gonna do this for turn right and turn up as well. So if the snake is already moving right vis-a-vis this sorry, if the self.x change is already greater than 0, meaning the snake is moving right, what I'm gonna have is I'm just gonna skip this function when it's called, or skip the additional function when it's called. So I'm gonna do this for turn up and turn down as well, but in this case it's gonna be with y. So if the y change is already less than 0, skip, and then finally greater than 0. So yeah, so essentially what this does is now if I go in here and I press the same arrow multiple times in a row, nothing happens, it's just normal, and the movement is correct. So this is quite long and very dense. And I think I'm gonna do this in 2 parts. So this is the first part of the snake object-oriented programming using pygame, creating this, and then I'm gonna make a new part soon, and I'll upload that right after this. I upload this part. So yeah. Anyway, I'll see you next time. I hope you watch the second part of this video or this series, I guess, to finish off the coding of this snake game. Anyway, thank you. Bye.